What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about layer 2 attacks such as ARP poisoning, MAC flooding, and MAC cloning. You're also going to learn about DNS attacks such as domain hijacking, DNS poisoning, URL redirection, and domain reputation. Let's talk about these layer 2 attacks. So the first one is address resolution protocol poisoning. So ARP poisoning, this is a technique by which an attacker sends spoof ARP messages onto a LAN. Generally, the aim is to associate the attacker's MAC address with the IP address of another host, such as the default gateway, causing any traffic meant for that IP address to be sent to the attacker instead. ARP spoofing may allow an attacker to intercept data frames on a network, modify the traffic, or stop all traffic. Often the attack is used as an opening for other attacks such as DOS attacks, man in the middle, or session hijacking attacks. The attack can only be used on networks that use ARP and requires the attacker to have direct access to the local network segment that is to be attacked. Next, we have media access control flooding, so MAC flooding. This is a technique employed to compromise the security of network switches. The attack works by forcing legitimate MAC table contents out of the switch and forcing a unicast flooding behavior, potentially sending sensitive information to portions of the network where it is not normally intended to go. Switches maintain a MAC table that maps individual MAC addresses on the network to the physical ports on the switch. This allows the switch to direct data out of the physical port where the recipient is located, as opposed to indiscriminately broadcasting the data out of all ports as an Ethernet hub does. The advantage of this method is that data is bridged exclusively to the network segment containing the computer that the data is specifically destined for. In a typical MAC flooding attack, a switch is fed many Ethernet frames, each containing different source MAC addresses by the attacker. The intention is to consume the limited memory set aside in the switch to store the MAC address table. The effect of this attack may vary across implementations. However, the desired effect is to force legitimate MAC addresses out of the MAC address table, causing significant quantities of incoming frames to be flooded out on all ports. It is from this flooding behavior that the MAC flooding attack gets its name. After launching a successful MAC flooding attack, an attacker can use a packet analyzer to capture sensitive data being transmitted between other computers, which would not be accessible with the switch operating normally. The attacker may also follow up with an ARP poisoning attack, which will allow them to retain access to privileged data after the switch recovers from the initial MAC flooding attack. Also, MAC flooding could be used as a rudimentary VLAN hopping attack. Next, we have MAC cloning. So MAC cloning, this is a technique for changing a factory assigned MAC address of a network interface on a network device. The MAC address that is hard coded onto the network interface controller, or the NIC card, cannot be changed. However, many drivers allow the MAC address to be changed. Additionally, there are tools which can make an operating system believe that the NIC has the MAC address of a user's choosing. The process of masking a MAC address is also known as MAC spoofing. Essentially, MAC spoofing entails changing a computer's identity for any reason. The main purpose for changing the assigned MAC address may allow a user to bypass access control lists on servers and routers, either hiding a computer on a network or allowing it to impersonate another network device. MAC spoofing can be done for legitimate or illicit purposes alike. All right, let's talk about some domain name system attacks, or DNS attacks. So the first one we're going to talk about is domain hijacking. And this is the act of changing the registration of a domain name without the permission of its original registrant, or by abuse of privileges on domain hosting and registrar software systems. This can be devastating to the original name holder, not only financially, as they may have derived commercial income from a website hosted at the domain or conducted business through the domain's email accounts, but also in terms of readership and or audience for nonprofit or artistic web addresses. After a successful hijacking, the hijacker can use the domain name to facilitate other illegal activity, such as phishing, where a website is replaced by an identical website that records private information, such as login passwords, spam, or may distribute malware from the perceived trusted domain. Next, we have DNS poisoning, also known as DNS spoofing, and this is a form of computer security hacking hijacking, in which corrupt DNS data is introduced into the DNS resolver's cache, causing the name server to return an incorrect result record, such as an IP address. This results in traffic being diverted to the attacker's computer or any other computer. A domain name system server translates a human-readable domain name into a numerical IP address that is used to route communications between nodes. Normally, if the server does not know a requested translation, it will ask another server, and the process continues recursively. To increase performance, a server will typically cache these translations for a certain amount of time. This means if it receives another request from the same translation, it can reply without needing to ask any other servers until that cache expires. When the DNS server has received a false translation and caches it for performance optimization, it is considered poison and it supplies the false data to clients. If a DNS server is poisoned, it may return an incorrect IP address, diverting traffic to another computer. Next, we have a uniform resource locator redirection. So a URL redirection, this is a vulnerability which allows an attacker to force users of your application to an untrusted external site. The attack is most often performed by delivering a link to the victim, who then clicks the link and is unknowingly redirected to the malicious website. This vulnerability exploits the inherent trust that a user has in the legitimate domain. Since the victim is generally unaware of URL redirections, they are considerably more susceptible to phishing and social engineering attacks. Next, we have a domain reputation attack. So domain reputation, this is a technique used to validate the authenticity of a domain and the services using such domains, such as the websites and email addresses. Domain reputation is used to track known malicious domains that point to websites hosting malware or those that are used for spam, phishing, spear phishing, or other malicious activities. And there are several technologies and standards that have been created for domain authentication and validation, such as the following. The first one is called Domain Keys Identified Mail, or DKIM, and this provides a means for gateway-based cryptographic signing of outgoing messages, which allows for you to embed verification data in an email header and for email recipients to verify the integrity of the email messages. Next, we have Sender Policy Framework, or SPF, and this enables recipients to verify the sender's IP address by looking up DNS records that list authorized mail gateways for a particular domain. And then we have domain-based message authentication reporting and conformance, also known as DMARC. And this is designed to thwart spammers from spoofing your domain to send email by preventing spammers from counterfeiting the from address on an email message so that it appears to come from a user in your domain. DMARC is designed to block these emails before they appear in your email inbox, and it also provides visibility and reports into who is sending email on behalf of your domain to make sure that only legitimate emails are received. All right, so that was my quick little class on layer 2 in DNS attacks. So let's go ahead and do some of this wonderful check on learning. So the first question is, an attacker managed to associate their MAC address with the IP address of the default gateway. In a result, the targeted host is sending network traffic to the attacker's IP address instead of the IP address of the default gateway. Based on the given information, which type of attack is taking place? Would this be ARP poisoning, URL redirection, MAC flooding, or DNS poisoning? So your IP address is sending packets to an attacker's IP address instead of the IP address of the default gateway, and the correct answer is, this will be address resolution protocol poisoning. That is the correct answer. Next question. Remapping a domain name to a rogue IP address. This is an example of what kind of exploit? Would this be DNS poisoning, domain hijacking, ARP poisoning, or URL hijacking? So remapping a domain name to a rogue IP address. This is an example of what? And the correct answer is, this would be DNS poisoning or domain name system poisoning. Next question. Which of the following attacks occurs when the threat actor sends numerous unknown MAC addresses to a network switch to cause a DOS condition or to sniff network connections over a switch network while disrupting network performance? Would this be a MAC memory leak attack, a man-in-the-middle attack, a MAC cache poisoning, or a MAC flooding attack? So which of these sends numerous unknown MAC addresses to a network switch to cause a DOS condition or to disrupt normal network performance? And the correct answer is, this will be a media access control flooding attack. All right, so in summary, we have talked about layer 2 attacks such as ARP poisoning, MAC flooding, and MAC cloning. We also talked about DNS attacks such as domain hijacking, DNS poisoning, URL redirection, and domain reputation. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.